Faraday's law of electromagnetic induction. So first of all, Faraday's first law tells us that the induced EMF will continue as long as there is a change in the magnetic flux linked with the coil. At the point where the magnetic flux becomes zero or the change in the magnetic flux is zero, the induced EMF will also become zero. The second law states that the induced EMF in a coil is directly proportional to the rate of change of magnetic flux. In other words, the greater the change in the magnetic flux per second, then greater will be the induced EMF. Here the number of turns remain constant, meaning that the induced EMF is proportional to the rate of change of magnetic flux. Now let's discuss all the factors on which the induced EMF depends. First of all, we have the change in the magnetic flux. The greater the change in the magnetic flux, the higher will be the induced EMF. Next, we have the number of the turns in the coil. The more the number of the turns, the greater will be the induced EMF. Then we consider the area of the coil and the angle between the magnetic field and the coil's vector area. As for external factor, the induced EMF is independent of them. For example, change in temperature, length and area can affect resistance, and when the resistance increases, the current decreases. However, since EMF is essentially a voltage, it remains constant. Therefore, we say that the induced EMF is completely independent of the material's nature.